Well, hello everybody. I'm with Mrs. Downs right now working on math stuff, so I'm sitting in warm Starbucks thinking about some math. And so, anyway, I'm not here today. So today we're going to talk about the law of cosines. And so the Common Core standard really is the law of cosines. Okay, I hope everybody has a calculator, and make sure your calculator is in degree mode. Alright, so you can do a real quick check on your calculator. So if I check on mine real quickly, go to mode, degree mode, I'm good to go. Alright, so when we were talking about the law of sines, one thing about the law of sines is you always had a pair of opposites. For example, let's say you had a 70-degree angle. Let's say this side was, I don't know, 15. I'm just making this stuff up, whatever. But if you have a pair of opposites, you use the law of sines, okay? But today, you're going to notice in example 1 that we do not have a pair of opposites. In fact, you look at it, you've got the 58-degree angle and you got the x. So you don't know a pair of opposites, but you do have an adjacent side, an angle, and adjacent side. Okay, so from geometry, we just call that side, angle, side. So if you know side, angle, side, then you can find the opposite side. So today what we're going to do is find the opposite side by the thing called the law of cosines. Right? Here it is. Law of cosines states it's the opposite squared is equal to the adjacent 1 squared plus adjacent 2 squared minus 2 times adjacent 1 times adjacent 2 times cosine of the angle. Okay. Now, since it is equal to the opposite squared, when you get all the way through this, you're going to take the square root of that answer to get it. Okay. So let's take a look at example 1. So example 1, I have two sides. I have two adjacent sides, and it doesn't matter, adjacent 1, adjacent 2, and I have an angle. So I'm going to set it up to find the opposite from the angle. That would be my opposite side is x, or rs, okay? So it would be the opposite side. So if I set this up, I'm going to write it out as x squared equals, because that's the opposite squared, equals adjacent side squared, 12 squared, plus the other adjacent squared, plus 10 squared, minus 2 times the adjacent, which is the 12, times the adjacent, which is 10, times the cosine of theta, but theta means angle, 58. Okay, so here it is. All right, I've got opposite squared is equal to adjacent squared plus adjacent squared minus 2 times adjacent times adjacent times the cosine of the angle. Well, it looks like a pretty big formula, but it's not that bad because just let the calculator do the work. Honestly, we'll just type it in. We'll go 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 58. That's why it's called the law of cosines, because we use cosine. Okay? Hit enter. Now, of course, that's x squared. So I have x squared is equal to 116.819 blah, 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 blah. But we need x. So we take the square root of both sides to get the value of x. And if I take the square root of my 116, I get about 10.8. Okay, so 10.8. Okay, so again, I ask myself, does that answer make sense? And if I look at the values here, yeah, 10.8 makes sense. Okay, so there's the value of x. Okay, good. So now, all of a sudden, if I need to find the rest of the triangle, I could, because I have my opposites, which we'll take a look at that in example 2. Okay. All right, so let's do example 2. Slide it up. Okay. So when I take a look at this triangle, I don't have the opposites, but I do have the side, angle, side. So if I have side, angle, side, I'm going to use the law of cosines. The law of cosines says opposite. Well, if this is angle F, then little f, angle F, little f is its opposite side. So I'm going to set it up. Okay. My formula says, well, I look at it, it says opposite squared. So I'm going to take little f squared equals adjacent squared, which is 7 squared, plus adjacent squared, which is 8 squared, minus 2 times the adjacent, which is 7, times the other adjacent, which is 8, times the cosine of the angle, which is 63. So all I'm doing is plug the numbers into the formula. That's it. Opposite squared equals adjacent squared plus adjacent squared minus 2 times adjacent times cosine of the angle. Okay? All right, now I'm going to put that in my calculator. So just put my calculator up here. It's it's really pretty easy. 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of 63 degrees. And again, that's f squared. So I'm going to take the square root of the 62.153 because that's f squared. So I take the square root of that answer and I get an answer of about 7.88. Alright, so again, I always like to ask myself, does that make sense? 7.88. Does that answer make sense? I'm like, yeah, if that's 7 and that's 8, 7.88 makes sense. That'll work. Okay, now I want to find either angle A or angle T. It doesn't really matter because I have a set of opposites. So if I have the opposites, okay, if I have the opposites, if I have a pair of opposites, I'm going to use the law of sines. The law of sines, okay? And that's what we learned last week. So let's find, let's find angle T. So to set it up, I like to write down what I know first, and I'm going to go sine of T over its opposite side. Remember, this is what we did yesterday, or on Friday, Thursday. Sine of T over 7 would equal sine of 63 over 7.88. Okay, law of sines. If you have a pair of opposites, use the law of sines. Let's multiply by 7. So I'll have sine of T equals 7 times the sine of 63 over 7.88. Okay, I'll just use my calculator. And we'll do that. I'll go 7 times sine of 63 divided by 7.88. And I get a decimal, but that's because I'm going to do the sine inverse. I get that sine of T equals my 0.791, blah, 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 blah. So what I need to do is just, because I need the angle, I'm going to take the sine inverse of that answer, of that 0.7915. So I'm just going to do that on my calculator. I'm going to go sine inverse of that answer, about 52.3. Okay, so angle T is about a 52.3 degrees. Okay, and again, I ask myself, does that answer make sense? Yeah, it does. Definitely makes sense. Okay, there's my calculator. There's my answer. So I'm going to put that in there. 52. Circle that. 52.3 degrees. Okay, good. And angle A, well, that's pretty easy because we add them up and subtract from 180. So angle A is going to equal just the 180 minus 63 plus 52.3 degrees. And I'll do that, 180 minus parentheses. You can see that. Parentheses 63 plus 52.3. And again, that's about 64.7. So angle A is about 64.7 degrees. Alright, so when do I use the law of cosines? I use the law of cosines when I do not have a pair of opposites. If I have a pair of opposites, I like the law of sines. It's easier, a little bit smaller, okay? Ready to turn the page? Alright. Now, you can also use the law of cosines to find an opposite angle. So if you don't have a pair of opposites, so if you look at example 3, in example 3 you do not have a pair of opposites. You have 3 sides, but not an opposite. So what are you going to do? Well, what we're going to have to do here is use the law of cosines because there's no opposites. So it says cosine of theta. So let's write that down. Cosine of theta. So if that's theta, then these are my 2 adjacent sides, okay? If I'm picking this angle, then the 10 is an adjacent side and the 17 is the other adjacent side. That would make the 18 be the opposite side, okay? So let's look at the formula. Cosine of theta. Now, one of the things I want to make sure you know, and watch, everybody watching, in your calculator you must have parentheses so that you divide correctly, okay? Anyway, let's do this. Let's go. Cosine of theta equals parentheses. Don't forget big parentheses. Cosine of theta equals big parentheses of adjacent squared, 10 squared, plus adjacent squared, 17 squared, minus the opposite squared. The opposite is 18 squared, parentheses, divided by, big divide by sign, parentheses, 2 times the adjacent, which is 10, times the adjacent, which is my 17. All right, now, let's go ahead and use the calculator to do this. Now, what I'm looking for is an angle, so the last step I will do is an inverse. But anyway, calculator out, have to have the parentheses. So important to have these parentheses because you want the entire top to be divided by the entire bottom. So, parentheses, 10 squared plus 17 squared minus 18 squared, parentheses divided by parentheses, 2 times 10 times 17 parentheses. Okay. Now I get a decimal, which it's kind of what I expected because I'm looking for the angle, right? So the angle can't be 0.19. That doesn't make any sense. But if I do the cosine inverse of 0.19117, blah, 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 I will get an angle, okay? Because I'm looking for the angle. In fact, it even says the last step should be then, highlight this, then cosine inverse of the answer, which is what I'm going to do right now. I'm going to go cosine inverse of the answer to get the angle, because I have to do the cosine inverse to get the angle. And I get an answer for about, how about 79? We'll just round it up to 79. 79 is pretty good, okay? So that means theta is 79. Decimal in the wrong place. Scratch up 79 degrees. There we go. Scribble that out. All right. So if you don't know a pair of opposites, use the law of cosines. All right. Example 4. Slide it up. All right. In example 4, what we're going to do is this. Again, we do not have any of the angles, so we have to pick one of the angles. So if there's an obtuse angle, I'm going to write a little note on this. Find the obtuse angle first. Okay, trust me on this. There's a reason why. Law of sines will never give you an angle bigger than 90. Cosines will, okay? Find the obtuse angle first, always, okay? Find the obtuse angle first, okay? Trust me on that, okay? So the obtuse angle is angle D. Okay, let me circle angle D. All right, good. Now, I do not have a pair of opposites, so I can't use the law of sines. I have to use the law of cosines. So if I'm going to find angle D, that means the 12 is my opposite, the 8 is my adjacent, the 6 is my other adjacent, all right? Let's set it up. So the formula says, okay, let's look at the formula real quick. There it is. Okay, so the formula says cosine of theta, or in this case, cosine of D, right? Because that's the angle I'm looking for. Cosine of D is equal to parentheses, don't forget your parentheses, adjacent 1 squared, 6 squared, plus adjacent 2 squared, 8 squared. So somebody's going to say which one's adjacent 1, adjacent 2. It does not matter. It does not matter which one's adjacent 1, adjacent 2. It does not matter. Minus the opposite, that does matter. Minus 12 squared, parentheses, divided by parentheses 2 times your adjacent times your adjacent. Okay, I'm just putting the numbers. Putting the 6 squared plus the 8 squared minus the 12 squared over 2 times the 6 times the 8. Okay, have to have parentheses. So now, what I want to do is actually do that. Use my calculator, put the calculator into this. Go ahead and clear that. I'll go parentheses, go 6 squared plus 8 squared minus 12 squared. Parentheses divided by parentheses 2 times 6 times 8 parentheses, enter. Okay, I get a decimal. That's kind of what I expected because I'm going to do the cosine inverse of that. So now I'm going to go cosine inverse of that answer because I'm looking for an angle. Anytime you're looking for an angle, you have to use one of the inverse buttons. I'm going to go simply cosine inverse of that number, of that answer, negative 0.458, blah, 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 blah. And I get about 117.3, okay? That makes sense for angle D. So angle D is about 117.3 degrees. Okay, so I'll put that in there, 117.3. Okay. All right, now I have to solve the triangle. So that's the next step I want to do. So once you have a pair of opposites, remember we talked about that. If you have a pair of opposites, 117.3 degrees and 12, just use the law of sines to get the rest. So I can either find angle I, or angle G. It does not matter. Since you're not here and I'm here by myself, I'm going to pick angle G, okay? So if I want angle G, I'm going to set up the law of sines, okay? Use the law of sines law of sines. So I'll set up sine of g over 8 equals sine of 117.3 over its opposite side, which is 12. Okay, sine of the angle over opposite side, sine of the angle over its opposite side. Sine of g over 8 equals sine of 117.3 over 12. Okay, now got to cross multiply, bring that up there. So I'll have my sine of g equals 8 sine of 117.3 divided by 12. I'm going to use my calculator to do that. Okay, slide that up so you can see a little bit more. 8 sine 117.3 divided by 12, and of course get a decimal because I have to find the angle. Okay, so I sine inverse that answer. That's going to give me the angle. So sine inverse, because it's the law of sines, of that answer, I get about 36.3 degrees. So angle G is about a 36.3 degrees. Okay, I'll put that in there. 36.3. Okay. Now the last angle is angle I. But that's pretty easy because with angle I, I'm just going to add them up, subtract from 180 because there's 180 degrees in a triangle. So for angle I, we're going to go 180 minus parentheses 117.3 plus my 36.3 to get the last angle. I use my calculator to show that. Clear that. I'll go 180 minus 117.3 plus 36.3, right? Get my calculator. Push enter. There it is, about a 26.4 degree angle. So angle I is about a 26.4 degree. All right, great. Moving along. Okay, example 5. Last but not least, area of the triangle. Okay, so now there's two ways to do the area. One is Heron's formula, which you read about. But there's an easier formula. So we could use Heron's formula, but I'm not going to. If you know an angle, if you know side angle side, I'm going to use the other formula. So I've got area triangle. We learned this last week. 1/2 adjacent side times adjacent side times the sine of the angle. Give me the area of a triangle. Okay, we learned this last week. So let's do it. Let's take our triangle and let's just use the 117 and the 6 and the 8 because those are two adjacents and adjacents and an angle, right? So you can pick any of the angles, any of the sides, you'll get the same answer no matter what. So I'll go area equals 1/2. My adjacent side is 6. My other adjacent side is 8 times the sine of the 117.3. Type that into the calculator and you will get the answer. Alright, so clear that out. Put that so you can see that. There you go. 0.5 or 1/2 times 6 times 8 times 117.3, and I get an answer of 2,815.2. Oh, that's wrong. Forgot to push sign. 0.5 times, I knew something. I thought that was kind of big. Times 6. See, that's why you check. I go, that's way too big. Times 8 times the sine of 117.3. And I get an answer of, now that seems better, 21.3. That's why we check our answers. 21.3, and that would be in terms of like centimeters squared or whatever happens to be, okay? All right, so homework for today, and I'll expect you to work on it even though I'm not here. Page 970, 1 through 8 all, 44, 47, 51, okay? And that's all I have.